Have you ever wondered what it would look like if we used only 5 digits instead of the 10 digits that we currently use in mathematics? Of course, this would drastically alter math as we know it. Toddlers would learn the counting 1, 2, 3, 4, 10, skipping numbers 5 to 9 completely. Mathematically, this would mean that all place values would be represented in powers of 5. For example, the number which previously have been 431, meaning this, would now become 3211, meaning this. This system would be known as the base 5 system, since all numbers would be written as a sum of coefficients multiplied by powers of 5, leading to the base being 5. Currently, for everyday mathematics in school and business, we use the base 10 system, more commonly known as the decimal system. This is because of the fact that we have 10 fingers, leading to its usage in the Hindu Arabic numeral system used worldwide. For example, the number 942 simply equals this. However, that is not to say that other base systems are not in use. For example, the binary base system, also known as the base 2 system, is the basis of modern computing and digital electronics, used because of the fact that it only has two digits, 0 and 1. When a power of 2 is reached, the number moves on to the next digit. For example, the number 60 in base 10 is written as 111100 in base 2, as 60 can be expressed as this. Similarly, the number 37 in base 10 is written as 100101 in base 2, as 37 can be written as this. Other base systems with bases greater than 10 make use of extra digits represented by letters, with the letter A representing 10, B representing 11, and so on. The most common example of this is the hexadecimal base system, also known as the base 16 system, used in RGB color codes. This base system uses 16 digits from 1 to F. Hence, the number 1249 in base 10 is written as 4E1 in base 16, as 1249 can be represented like this. Similarly, the number 16 in base 10 is written as, you guessed it, 10 in base 16, as it can be represented as this. In hindsight, even though 10 is a pretty satisfactory number to have as a base, 12 would be logically better. I mean, think about it. Not only does 12 have more divisors, but it would also be much easier to represent time, degrees in circles, and general numbers if we used base 12. All in all, I'm just glad mathematicians back in the day didn't decide to use a huge number like 47 for the base system. Learning 47 whole digits would practically be like learning a new language.